Hi, in this video, this is a GCSE higher paper walkthrough. As always, please do stop the video, have a go at each of the questions. If you're not sure about anything, always add a comment below. I'll always come back to you. I look forward to seeing you inside the video. Hi, so this is the third video in the series where we're looking at the Edexcel, and it's the higher tier paper 2 maths paper from June 2019. Please do stop the video, have a go at each of the questions. We completed last video to question number 16, so we're going to be starting with this one from question number 17 onwards. I've got to say that these particular questions for the next few questions are going to be quite challenging, so hopefully this will be okay for you. I'll do my best to kind of work it through. So the first one is there's small cubes and some large cubes in a bag. Cubes are red, other cubes are yellow, and then it gives you a couple of ratios, and it says explain why the least possible number of cubes in the bag is 88. Well, the reason that is because this ratio here is 11 and this ratio here is 8, okay, and 88 is the lowest common multiple of 11 and 8, okay, and that would get you the mark for that particular question. So you need to read it through as you're going through this particular video. Okay, then it says, and this is perhaps a little bit trickier, but then it says all the small cubes are yellow, work out the least possible number of large yellow cubes in the bag. Okay, so let's have a look at what we've got. Well, we know there's 88 cubes, and we also know that there's two ratios. There's a ratio of small to large, which is going to be 4 to 7, and then there's a ratio of red to yellow, which is going to be 3 to 5. Okay, now we need to put ourselves in a position where actually we look at 88 cubes. So if I've got 11 cubes here and I multiply by 8, that's going to give me 32 small cubes and 56 large cubes. Likewise, if I've got red and yellow cubes, and I've got 3 red ratio and 5 yellow ratio, that's 8 cubes in total. I'm going to multiply that by 11, so that's going to give me 33 to 55. So what we're basically saying is that there are actually 55 yellow cubes in the bag itself, okay? Now, we know that 32 of them are small, so therefore the 55 take away the 32 small yellow cubes is going to equal 23 large cubes, and that is actually the answer to that particular question. So a little bit more challenging. Please do take the time to work through each of these questions. If you're not sure, add a comment below. I'll always come back to you if I can. Okay, so let's have a look then at question number 18. So question number 18 is kind of a circle theorem type question, becoming quite popular with both calculator and non-calculator papers. So in this particular one, it's not too bad, because if you look at the diagram, ABD is actually an isosceles triangle because AB and BD are equal to each other. So that allows us then to work out the base angles. Now, it does say give a reason for each stage of your working, so I'll try to sort of jot these down, but forgive me, just for the purposes of the video, I want to make it as quick as possible, and also my writing is pretty ropey. Okay, so ABD is isosceles, and therefore base angles the same. Okay, so it should be fairly easy to work through because we know that the top angle is going to be 40. If we take that away from 180, it means that these two angles are going to be 70 degrees each. So we know this is 70 and this is 70 degrees, okay? So if I just put equals 70 degrees there. All right, that's fine. So the next thing is that we know that A, B, C, and D is a cyclic quadrilateral, okay? So therefore, we're saying that this angle over here must be equal to 110 degrees. Now, the reason that is because opposite angles in a cyclic quadrilateral add up to 180. So if I put in here something like ABCD as a cyclic quadrilateral, okay, and if I put therefore angle BCD equals 110 degrees. Okay, so those are a couple of reasons, and that will give us then this particular angle. Now, you might well have spotted that actually BCD is also an isosceles triangle because of these two little lines here, and also it does tell you in the text as well. So if BCD is an isosceles triangle, it basically means, again, that the base angles are the same. So that one is the same as that one. So I'll just put in here BCD is isosceles. Okay, therefore, and if I put base angles same. Okay, so if we just take 110 away from 180 and then divide by 2, it means this and this must be 35 degrees. Okay, so therefore that's going to equal 35 degrees. Okay, so we're in a position now, we're being asked in the question to actually work out this angle here, which is angle ADE. Well, it's a straight line, so CDE is a straight line, and because of that, we know then that we've got a couple of actual angles that we can use. We've got this one 35 and this one 70, so we do 180 minus 70 minus 35, so the answer is going to be 75 degrees, which is the angle ADE as it is in the question. Now you might want to elaborate a little bit on this, it's just for the purposes of this particular video, but I hope it's been useful to you. Okay, let's move on then to question number 19. Question number 19 is a Pythagoras question. Just takes a little bit of working through, but not too bad. We're going to be using a combination really of Pythagoras and SOHCAHTOA for it, but you need to be just reading the text very carefully. But what we're basically saying is that there is a point on DA, so that DM to MD is 2 to 3. All they really mean by that is if we put this sort of point M here, that D to M is 2/5 of the way and M to A is 3/5 of that dimension. So actually we do know now that if this overall is 15 centimeters, then 3/5 of 15 centimeters will fairly easy to work out and will actually give us this dimension across here, which we might well need. Okay, so the first thing I'm going to do is we need to calculate the size of EM and the base. So basically we're looking at this kind of triangle. Okay, now hopefully that's come across okay on the video, but the first thing I would do is that if we've got this triangle, I'm going to find out this first. So this is going to be helpful in working out this angle that we're looking for in here. In order to work out the angle that we're looking for in here, what we're going to do is we're going to be using eventually SOHCAHTOA, because we're going to find this size and we're also going to find this size along here. Okay, so EB, well, that's not too bad to be able to work out. I'll try to sort of show this on the screen as much as I can. But if I look at this triangle here, and what I'm doing is just a little sketch of this end piece here, where I've got A, E, B. Now I know that this is 35 degrees and I know this is 15 centimeters. Okay, so it's also opposite. EB is opposite and AB is the adjacent. Okay, so if I put that into the SOHCAHTOA relationship. I'm sorry, I've had to change pens there. I just noticed that my pen was running out. Okay, what I've got is I know the tangent of the angle. I'm looking for the opposite, which is this one here, and I know the adjacent, so I'm going to use the tan ratio. So tan of 35 degrees is equal to the opposite, which is EB, divided by the adjacent, which in this particular case is 15. So if I cross multiply by 15, what I'm going to get is that EB is going to equal to, I'll put the whole number in here, 10.503 17307. Okay, so again, don't worry too much about writing all the numbers, but it is kind of helpful if you do that. Okay, so now what we know is that this edge of the triangle is 10.5 dot dot dot. Okay, which is absolutely fine for us. The last thing I want to do is I want to work out this edge along here, which is going to be MB. Okay, so if I just draw a little sketch for you at the bottom here, I'm going to have another triangle. Okay, and what I've got is MB. Now, I've drawn this slightly differently. What you'll see is that actually this triangle is lying flat. It's on the base over here, where this is 15. Okay. And this along here is 3/5 of 15 centimeters, which is actually going to be 9 centimeters. Okay, so hopefully you can see that I've just taken what is something very flat and then I've just put it upright. Okay, because what then allows me to do is to use Pythagoras, and you remember that I need to work out MB. Okay, so it's MB is the bit I'm interested in. So I'm going to use a squared equals b squared plus c squared, but I'm very sure that other people will use c squared equals a squared plus b squared. It's perfectly fine, doesn't really matter, providing you know that you're looking for the square on the hypotenuse. So in this particular case, it's going to be 9 squared plus 15 squared, so therefore a squared is going to be 306. So MB is going to be the root of 306, which equals, I'm going to write it as 3 root 34. I could, if I wanted to, write that out as the decimal equivalent. It'll just take a little bit more time to do that. Okay, so we're now thankfully in a position where actually what we do know, we go back to our sketch, is we've got the height of this triangle is that, and then the length of this triangle is going to be 3 root 34. Okay, which is brilliant for us because we're now in a position that we can then calculate this angle. And to do that, we're going to again use SOHCAHTOA. So basically, if I just sketch that out for you, I've got another triangle. Now this is the upright triangle where I've got EB at one end, which we've worked out is 10.50317307, which is this length here. And then we've also got this MB base, which is going to be 3 root 34. Okay, now you'll remember what we're trying to do is we're trying to figure out this angle. So therefore, I'm going to use the tan rule because this is the opposite. And again, this is the adjacent. So it's actually the same as choosing this one at the top here because I know the opposite, I know the adjacent, and then I need to find this particular angle. So therefore, I can say that tan of x, we'll call it x if you like, which is this one here, is going to equal to the opposite over the adjacent. So I can just plug those numbers in, which is going to be 10.50317307 divided by 3 root 34. Put that into a calculator, but don't forget that what this will give you is the tan value. So actually what you need is the inverse trig. So it's tan to the power of -1, and then 10.503, oh dear me, 17307, all divided by 3 root 34. Put that into a calculator and you should be able to access this by using Shift tan on a scientific calculator, and that's going to give you 30.9817, which in answer to the question correct to 1 decimal place is going to equal 30.1 degrees. Okay, and that would be the answer to question number 19. Okay, so the very last question in this particular paper is question. Okay, so on to question number 20. This is quite a tricky question. It's actually going to spread over to a couple of pages, perhaps on the back of this sheet. So please do stop the video, have a go, but also make a sketch of this little quadrilateral here because it will help. Okay, so express vector FE in terms of A and or B. So vector FE, we don't know anything about, it's this one along here, but we do know these vectors because we're told it in the text itself. So FE is going to be a combination of vector FC plus CD plus vector DE. Okay, so let's look at FC. Well, according to the information, that's going to be A minus B, which is this one here. And then we've got CD, which is going to be A, and then DE, which is going to be B. Now, minus B and plus B cancel themselves out. So therefore, vector FE is going to be equal to 2A. And that's actually the answer to the first question. So if you do get that, that's brilliant. You've got 2 marks out of the 6 on offer with this particular question. The second part of the question, however, is much more challenging. So let's have a look at how we can work this out. We're being asked to find the value of n because we've got f to x and x to m. So basically, fx multiplied is fm. So, or if you prefer, you've got a ratio where if this xm is 1, then f to x is a multiple of 1. Now, I don't know whether that is the case, but it is the case, but I don't know whether xm is going to be 1. Let's work it out and see what happens. So the way I'm going to do this is I'm actually going to draw a line between C and E through X because it will help me then to use a device called matching coefficients, and you'll see what I mean as we move a little bit further into this particular question. Okay, so the first one is we've got quite a lot of information here. It says work out the value of n. So the first thing I'm going to say is that actually if I look at f to x, if I multiply fx, I get fm. Okay, I'm not going to be multiplied by, it's going to be a coefficient, it's going to be a small coefficient, so it could be a half or something like that, I don't know. But I can write that as fx equals a multiple of fm. Okay, so similarly, I've got exactly the same with cx and ce. I can say that vector cx, and in this particular case, I'm going to say it's a multiple of CE, but I'm actually going to call it Y. Okay, so what I've done is I've differentiated X and Y's there. Okay, so let's have a look then at what we can do in order to kind of help us a little bit more with this particular question. So the first thing is I'm going to look at FM. So FM is going to be equal to vector FC plus vector CD plus vector dm. Okay, now FC I'm given as a minus b and CD I'm given as a. Now dm is half of de, which we've been told is actually b, so therefore it's a half of b. If I then sort of simplify all of that, bring the a's together and bring the b's together, I'm going to get 2a minus a half of b. Okay, so what I now know is that vector fm is 2a minus a half of b. Let's do the same with vector ce. Okay, so vector ce is this one over here. Okay, well that's going to equal vector cf plus fe. Okay, well we know that fc is going to be a minus b. It's in the opposite direction as cf, so therefore it's going to be minus a minus b, and we know that fe is going to be 2a because we worked that out in the first question, so that's therefore going to be plus 2a. Okay, when I simplify all of that together, I've got minus a plus b plus 2a. That will all work itself out as going to be a plus b. So now I've got two vectors. I know fm and I know ce. Okay, so let's have a look then at fx. Well, if I know that fx is a function of x, okay, then, or function of fm rather, then I can write vector fx as being a multiple of x of these. So I could write, if I wanted to, as x times 2a minus a half b. Okay, I'm going to just take this out a little bit and multiply that by x. I'm going to get 2xa minus a half x b. Okay, so hopefully that's okay for you. It's quite crucial to look at that part of it, because similarly I can do exactly the same with ce. So if I look at vector cx, now bear in mind here, it's a multiple of y of that, so therefore it's going to be equal to y times a plus b, which is going to equal ya plus yb. All right, so I'm now in a position that I've got this vector cx, and I've got also this vector fx. Okay, so hopefully this is okay for you. The last thing I need to look at is I need to look at cx. Now, what I've got is that cx also is equal to vector cf, okay, plus vector fx. And I've now got enough information to be able to add these things together, because what I'm looking at really is I know that cx is that, and also if I go back, I also know that cx is a combination of that plus that. Okay, so I've got my value of vector cx in two different ways. So let's have a look at how we can actually calculate that. Well, again, we're told that cf is minus a minus b, because we know the value of fc, and we know that fx now is what we've just worked out here, which is going to be plus 2xa minus a half xb. All right, now this is where it does get a little bit tricky. Okay, so what I'm going to do is I'm just going to move it on to the next part of it on a separate piece of paper. So bearing in mind this is the value of cx, and bearing in mind this is also the value of cx. So what I'm going to do is I'm going to make those two equal to each other, and then I'm going to use matching coefficients to be able to work out the values. Okay, so let's have a look and see what happens. So what I'll do is I'll just write on the back here the actual information I've got. Vector cx. Okay, so we said it's minus a plus b plus 2xa minus a half xb, and that equals vector cx, which is equal to ya plus yb. Okay, right, so again, it looks a little bit scary canary, but you know, it shouldn't be too bad, because effectively what I've got is if I bring the a's together, I'm going to get 2xa minus a, and if I bring the b's together, I'm going to get plus b minus a half xb. Okay, now if you can see here, these are values of b and these are the values of a, and that equals ya plus yb. Okay, so let's have a look firstly at the values of a. Okay, so this is this one here. What I end up with is saying that if you like, so let me look at A here. Okay, so this is this A relationship. So what I'm saying is that YA equals 2XA minus A. Well, I can afford to get rid of the A's by dividing everything through by A. So therefore, I get Y equals 2X minus 1. Okay, so that's my first value of Y. Okay, so I don't know how you are with this. There are some other videos on the channel that might give you a little bit more support and a bit more of an idea. It is quite a tricky question, but hopefully you're bearing with me. So let's look now at the values of B. Okay, so the values of B, again, I'm going to match the coefficient with this and this. So I'm going to say that YB equals B minus a half XB. Okay, so if I divide through by B, I'm going to get Y equals 1 minus a half X. Okay, so therefore I've got two values of Y, which is brilliant because now what I can do is make those two equal to each other. So if I make 2x minus 1 equal to 1 minus a half of x, it's then really just a case of solving for x. So 2x plus a half x is going to be 2.5x, and that's going to equal to 1 plus 1 is going to be 2. So therefore x equals 2 over 2.5. Not very pleasant, so I'm going to change that to 20 over 25, which will reduce to 4/5. Okay, excellent. So I've now finally got my value of x. So going back to all the work that we did before, we knew that the function of x, or fx, sorry, not the function, the vector of fx equals x times vector fm. Okay, well now finally we know that x is 4/5 of vector fm. Okay, and that's the bit of information we need, because then we can work out that the ratio therefore must be 4:1, and therefore n equals 4. Okay. My goodness me, that's quite a tricky question. Hopefully it's been useful to you. I will put a copy of this actually on 3-minute maths as a complete level of working, I think. So at least you'll be able to refer back to it. But I hope it's been useful. Please do add a comment if you're not sure about anything, and I'll look forward to seeing you inside the next video.